Look up. On a clear dark night, far from the glare of city lights, you might see it. A faint, glowing band stretching across the heavens. Our ancestors gave it many names, but we know it as the Milky Way. This is not just a collection of distant lights, it is our home. We are inside it, looking out. We live on a tiny planet orbiting a humdrum star, tucked away in one of its vast, spiraling arms. From our vantage point we see our galaxy edge on, a shimmering river of starlight. That has inspired wonder for as long as humans have looked to the sky. This celestial river is a place of unimaginable beauty and scale. Imagine soaring above it all, looking down upon our galactic city. You would see a breathtaking pinwheel of light, 100 billion stars swirling in a cosmic dance. The spiral arms, like ethereal brushstrokes, are aglow with the fires of countless suns. These arms are the stellar nurseries of our galaxy, regions where new stars are born. They are painted with vibrant clouds of gas and dust, glowing nebulae in hues of pink, blue, gold. These clouds are the raw materials for creation, the very stuff from which stars and planets are made. This grand structure spinning slowly through the void is a testament to the organizing power of gravity. Within these glowing arms, the universe is alive with activity. The sheer scale of our Milky Way is almost impossible to grasp. It spans over 100,000 light-years from one edge to the other. A light-year is the distance light travels in a year, a journey of nearly 6 trillion miles. To cross our galaxy, even at the speed of light, would take 100 millennia. It is a vast and sprawling metropolis of stars, gas, and dust, all held together by the invisible hand of gravity and an even more mysterious substance we call dark matter. Our Milky Way is not just a collection of stars, it is a galaxy of worlds. For every star you see, and for the billions you don't, there are likely planets orbiting them. Think about that for a moment. Hundreds of billions of stars and perhaps even more planets. That's more worlds than there are grains of sand on all the beaches of Earth. These planets come in all shapes and sizes. There are gas giants larger than Jupiter, rocky super-Earths, and icy worlds wandering in the dark. Our own solar system with its familiar family of planets is just one of countless planetary systems scattered throughout the galaxy. For much of human history we could only wonder if other worlds existed. Now we know they do. Our telescopes have discovered thousands of exoplanets, planets orbiting other stars. We have found hot Jupiters orbiting so close to their stars that their atmospheres are boiling away. We have found rocky planets in the habitable zone, the region around a star where conditions might be just right for liquid water to exist on the surface. Each new discovery brings us closer to answering one of the greatest questions of all: are we alone? The sheer number of planets in our galaxy makes it seem almost inevitable that some of them could harbor life. What might that life look like? It could be simple microbial life, thriving in the oceans of a distant water world. Or it could be something far more complex, something we can't even imagine. The chemistry of life on Earth is based on carbon and water, but could life elsewhere use a different chemistry? Perhaps there are silicon-based life forms on a world with a methane atmosphere. The universe is not limited by our imagination. The possibilities are as vast as the galaxy itself. To understand the future of our galaxy, we must first journey back in time, all the way back to the beginning. About 13.8 billion years ago, our universe was born in a cataclysmic event we call the Big Bang. In the first moments, there were no stars, no galaxies, no planets. The universe was a hot, dense soup of energy and fundamental particles. It was a place of perfect uniformity, a cosmos without structure. But it would not stay that way for long. Tiny, quantum fluctuations in this primordial soup would become the seeds of everything we see today. As the universe expanded and cooled, gravity began its patient work. It started to pull matter together. The matter in the early universe was not just the ordinary stuff that makes up stars and planets. Most of it was an invisible, mysterious substance we call dark matter. We can't see it, we can't touch it, but we can detect its gravitational influence. It was dark matter that formed the first cosmic structures, creating vast, invisible scaffolds throughout the universe. These scaffolds became the gravitational wells into which ordinary matter, mostly hydrogen gas, helium gas, began to fall. Over hundreds of millions of years, these clouds of gas grew larger and denser. Gravity squeezed them tighter and tighter, until the pressure and temperature at their cores became so intense that nuclear fusion ignited. The first stars were born. These were not like the stars we see today. They were giants, hundreds of times more massive than our sun, and they burned with a ferocious intensity. They lived fast and died young, exploding in massive supernovae that seeded the universe with the first heavy elements. These explosions were the birth cries of a new cosmic era. These first stars were the building blocks of the first galaxies. They clustered together, drawn by their mutual gravity, forming small, irregular protogalaxies. These were the humble beginnings of the grand spirals, ellipticals we see today. Our own Milky Way is the result of billions of years of such mergers, a cosmic quilt stitched together from countless smaller galaxies. Galaxies are not static objects, they are dynamic evolving systems. The engine of that evolution is the life cycle of stars. Within the spiral arms of the Milky Way, vast clouds of cold gas and dust collapse under their own gravity, fragmenting into thousands of dense cores. Each core will become a new star. Starbirth is happening right now across our galaxy. The Orion Nebula, a fuzzy patch you can see with binoculars, is one such stellar nursery. New suns and new worlds are being forged there, a celestial cradle rocking with new beginnings. As stars age, they change. They fuse lighter elements into heavier ones. Our sun fuses hydrogen into helium. More massive stars create heavier elements. Carbon, oxygen, iron. These elements make up our planet and our bodies. We are quite literally made of stardust. The atoms in your left hand might come from a different star than those in your right. Every star is a cosmic furnace, forging raw materials for future stars, planets, perhaps life. The death of a star can be as important as its birth. A massive star that runs out of fuel collapses, then rebounds in a supernova explosion. For a brief time, a supernova can outshine its entire galaxy. These explosions are beautiful and essential. They blast heavy elements into space, enriching the interstellar medium. That enriched gas and dust becomes the raw material for new stars and planets. A grand cosmic recycling program. This cycle of birth, life, and death enables galaxies to evolve. Our galaxy is a living, breathing ecosystem renewing itself. The death of one star provides ingredients for the birth of another, and the cosmic story continues. Galaxies do not live in isolation. They're social creatures bound together by gravity into groups and clusters. Our Milky Way is part of a small gathering called the Local Group. It's like a cosmic neighborhood of about 50 galaxies dominated by two large spirals, our Milky Way and the Andromeda galaxy. The other members are mostly smaller dwarf galaxies, many of which orbit the two giants like moons around a planet. This cosmic community is in constant motion, a slow, gravitational dance that's been unfolding for billions of years. We are all waltzing through the universe together. Sometimes this dance brings galaxies a little too close. When two galaxies pass by each other, their mutual gravity can have, dramatic effects. They can pull long streams of stars and gas from each other, creating beautiful tidal tails that stretch for hundreds of thousands of light years. These gravitational interactions can distort the galaxy's shapes, warping their spiral arms and triggering bursts of new star formation as gas clouds are compressed. It's a form of galactic conversation, a dialogue written in the language of gravity. These close encounters are a key part of how galaxies change and evolve over time. Occasionally, the dance leads to a more intimate embrace. If two galaxies are on a collision course, they can merge to form a single, larger galaxy. Now, this might sound like a catastrophic event, a cosmic car crash of epic proportions. But space is mostly empty space. When two galaxies collide, the individual stars within them rarely, if ever, hit each other. Instead, they pass through each other like ghosts. The real action is with the vast clouds of gas and dust. These clouds slam into each other, triggering a massive wave of star formation known as a starburst. These galactic mergers are transformative events. They can completely reshape the galaxies involved. Our cosmic dance partner in the local group is the Andromeda galaxy. It is the closest major galaxy to us, about 2.5 million light-years away. On a dark night, you can just barely see it with the naked eye, a faint, fuzzy patch of light in the constellation Andromeda. What you are seeing is the light from over 1 trillion stars, and it is getting closer. Every second, the Andromeda galaxy is hurtling towards our Milky Way at a speed of about 70 miles per second. This is not a near miss, it is a direct, head-on collision course. The die has been cast. This cosmic rendezvous is not something to worry about in our lifetimes. The collision will not begin for another 4.5 billion years. That's about the same age as our planet Earth. By that time, our sun will have become a red giant and life on Earth will likely be long gone. But the universe will continue its story. The merger of the Milky Way and Andromeda will be one of the most significant events in the history of our local group, a celestial spectacle of unimaginable grandeur. It is a future that is written in the laws of physics, a destiny we can predict with confidence. As the two galaxies get closer, their gravitational influence on each other will grow stronger. Long before the main disks collide, they will begin to pull streams of stars and gas from each other, creating vast tidal bridges and tails that span the space between them. Our night sky, if anyone is around to see it, will be transformed. Andromeda will grow larger and larger, eventually filling a huge portion of the sky. It will be a stunning and somewhat menacing sight. The familiar constellations will be overwhelmed by the brilliant light of our approaching neighbor. The main event will be a slow-motion collision that takes hundreds of millions of years to unfold. The first pass-through will not be the end of the story. The two galaxies, now distorted and intertwined, will be irrevocably bound by gravity. They will slow down, pull back, and swing around for another pass. This cosmic dance of destruction and creation will continue for hundreds of millions, perhaps even a billion years. With each pass, the two galaxies will lose more of their distinct structure. Their spiral arms erase their stars, thrown into new, chaotic orbits. The orderly disks of the Milky Way and Andromeda will be scrambled into a single, massive, disorganized swarm of stars. Out of this chaos, a new order will emerge. The combined remnants of the two galaxies will eventually settle down into a new, stable configuration. A new, giant galaxy will be born. Some astronomers have already given it a name, Milkomeda, or perhaps Milkdromeda. This new galaxy will not be a beautiful spiral like its parents. It will be a giant elliptical galaxy, a vast roundish ball of stars. It will be larger and more massive than either the Milky Way or Andromeda, a new king of the local group. The sky of a planet within Milkomeda will look very different from our sky today. The familiar faint band of the Milky Way will be gone. Instead, the night sky will be more uniformly filled with stars, a vast glittering sphere surrounding any observer. The era of furious star formation triggered by the merger will be over. The gas and dust will have been used up or blown away. Milkomeda will be an older, quieter galaxy, with very few new stars being born. It will be filled with older, redder stars, a galaxy entering its twilight years. This is the ultimate fate of our cosmic home. Our Milky Way, the galaxy that has nurtured our sun and our planet for billions of years, will be gone. But it will not be destroyed. It will be transformed. The story of Milkomeda forces us to confront the immense scales of the universe. We think of our lives, our histories, our civilizations as long, but on a cosmic calendar, all of human history is but a fleeting moment. The 4.5 billion year countdown to the Andromeda collision is a time span so vast, it is almost beyond our comprehension. It reminds us that we are newcomers to the universe, brief players on a stage that is billions of years old, and that stage will continue for billions more. Our existence is a precious, improbable flicker in the grand expanse of cosmic time. The universe is not just old, it is vast. The 2.5 million light-years to Andromeda is just a neighborhood stroll. Our local group of galaxies is just one of thousands in the Virgo supercluster. The Virgo supercluster is just one tiny filament in the vast cosmic web, a structure of galaxies and voids that stretches across billions of light-years. There are hundreds of billions of galaxies in the observable universe, each one a sprawling island of stars, planets, and possibilities. To contemplate this scale is to feel a sense of profound humility. We are but a speck of dust in an infinite ocean. This perspective is not meant to make us feel small or insignificant. On the contrary, it should make us feel special. On this tiny planet, in this remote corner of the Milky Way, something amazing has happened. A part of the universe has become self-aware. We, the Stardust, have evolved to a point where we can look back at the cosmos and begin to understand its story. We can use the tools of science to piece together the history of the universe and to predict its future. We are the universe's way of knowing itself. That is a powerful and wonderful thought. Embracing this cosmic perspective can change the way we see ourselves and our world. The conflicts and divisions that seem so important on Earth fade into insignificance when viewed against the backdrop of the cosmos. We are all citizens of the Milky Way, all passengers on spaceship Earth. We share a common origin in the stars and a common destiny in the universe. Understanding our place in the cosmos connects us not just to each other, but to the entire fabric of space and time. It is a perspective that inspires awe, wonder, and a deep sense of connection to all that is. So the next time you find yourself under a dark, starry sky, take a moment. Look up, feel the vastness of the space above you. Each point of light is a sun, a star, perhaps with its own family of planets. You are seeing them not as they are now, but as they were in the past, when their light began its long journey to your eyes. You are looking back in time. You are seeing a snapshot of the cosmic story, a story of birth evolution transformation that stretches across billions of years and unimaginable distances. Know that you are part of this story. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were forged in the hearts of stars that lived and died long before our sun was born. You are connected to the cosmos in the most intimate way possible. When you look at the stars, you are looking at your own cosmic ancestry. You are seeing the furnace that created the building blocks of you. This is not poetry, it is physics. It is a fundamental truth about our existence. By looking up at the stars, by studying the universe with our telescopes, by studying the universe with our minds, we are participating in that story. So go outside, look up, and let the cosmos fill you with awe. You are not just looking at stars, you are witnessing the endless unfolding story of the universe.